So after discovering the charge on the electron in the Millikan-Fletcher oil drop experiment, they actually returned to that and also used the cathode ray tube in order to discover the mass of the electron itself. It may not sound like a whole lot, but it has become significant in various areas of research. Okay, so you don't need to remember this, all right? I wanted you to just look at it. Okay, so if you look at the relative electric charge, okay, so they were able to discover that the electron and the proton have equal but opposite electric charges. Okay, so that is actually pretty significant, especially when you look over at the relative mass. So AMU is atomic mass units. Okay, you can see what that actually relates to in terms of kilograms here. It's an incredibly small number, okay? But if you look at the actual numbers, okay, the mass of both a proton and a neutron are relatively similar. In fact, they're usually referred to as having the exact same mass. But if you look at the mass of an electron, it's so much smaller than a proton or a neutron. And so generally we just kind of ignore its mass, and we say it really doesn't have much of a mass at all. So its mass number is 0. Okay, so an electron that doesn't have like any mass has the same but opposite electrical charge as a proton. Okay, so it's very different. We'll get into the symbols when we start talking about radioactivity, so don't worry too much about those just yet, but just wanted you to know that that is how they figured out charges and mass. Okay, and then a couple jokes just in this section. Don't trust atoms, they make up everything. Haha. Yeah. Adam says, I've lost an electron. Another one says, are you positive? Because if you lose an electron, you become more positive. Become a cation. And then a final joke. Neutron walks into a bar. Asks the bartender, how much for a drink? Bartender says, for you, no charge. Get it? Because neutrons don't have a charge. Anyway, before y'all start to hate me too much, that is the end of this section.